So let's start. For today's topic is about ICL sizing by anterior segment OCT, measurement of scleral spur to scleral spur. This is my financial disclosure. And we're talking about the as-oct MS39. And there are a lot of applications, but applications we will use for the measurement of scleral spur to scleral spur are the arterial chamber measurement, and also when doing refractive surgery with faded KOLs, the dry eye anterior film analysis is very interesting. Why the MS39? Because of the automatic acquisition of the anterior segment parameters. It has a high repeatability amongst people who use it, amongst technicians. The measurement is very fast, it's non-invasive and patient-friendly. Now, actually the goal was how to make ICL sizing predictable, easy and repeatable. The Preop Evaluation is of course extremely important, and first of all, when you've done the acquisition, it's very important to check whether the quality of the acquisition is good enough. And you can see here the coverage 100%, centration is very good. So you can be sure that this acquisition is done in a high quality, and you can use this for further evaluation. The other parameters I check is the breakup time. That is the non-invasive breakup time, which gives you very nicely when the tear film breaks up and when it is the median, and it gives you also a visualization of it, where the tear film is breaking the fastest. Another map to consider is the choice of the 4 different maps on the CSO machine. You can see here, and this is a button on the left hand side, left upper, and always click on that to judge the epithelial thickness map, because the epithelial thickness map gives you a lot of information about the refractive status of the eye, what is the influence of the dry eye on the epithelium, and when you have a dry eye and or epithelial thickness which is not homogeneous across the cornea, first treat the dry eye, let the patient come back 4 to 6 weeks later after being treated and remeasure, because it can have a huge influence on your refractive outcome. Another parameter we check with ICL sizing is the anterior chamber depth, and you can find it here on the map. The corneal thickness plus anterior chamber depth is 555 microns and about 3 millimeters of depth of the anterior chamber measured from the endothelium to the front part of the lens capsule. Then the angle to angle is measured, and also the anterior chamber width or the distance between the scleral spurs. The machine also gives you where the measurement was done. So here it is in the horizontal axis. Always check that it was in the horizontal axis, because you're going to place the ICL exactly there. And of course the crystalline lens riser, which is called the CLR, which is the distance between the straight line connecting both ARs and the anterior surface of the crystalline lens. But when looking at the image, actually the OCT image, it is not a straight line. Why not? Because there are different refractive indexes for the cornea and the aqueous in the anterior chamber. So actually when you look at the map, it is more a curved line. The calculation is being done by the MS39 itself. So when you try to measure it yourself between scleral spur to scleral spur, you will not get the same result. So don't try and attempt it, because the refractive indices are changing. So the machine does it for you. No need to do it by yourself. And again, the scleral spur to scleral spur is on the map here, 11.84. The lens right is minus 0.16. So all the measurements are being done by the machine and given to you directly. No need to calculate. The only thing you have to do is the calculation of the ICL sizing yourself. And there was a paper published in Ophthalmology in 2018, American Journal of Ophthalmology 2018, by Nakamura, a Japanese eye surgeon, and he said like the optimal ICL size is that equation. Now this will not be exactly the same for this machine. We're working on this closely together with CSO. We have already 100 eyes in our database, and we will come out probably next year with an optimized formula for the ICL sizing with the MS39 of OCT. So let's take the eye which we measured previously and do the calculation. Okay, here we go. So when you put in the numbers, what I told you before, the scleral spur to scleral spur and the lens rise, and when you do the calculation, you end up with a 12.62 millimeters. And this is what we do then. We use the 12.6 millimeter ICL. Now, this instrument is also very useful in post-op evaluation. Now you can measure the volt of the ICL post-operatively. You can, this is in 36 eyes, the evaluation of the volt done with the calculation at scleral spur to scleral spur. As you can see, 12 months after surgery, it's in the purple bar. All eyes are within 100 microns volt to 900 microns volt. This is where you want to be. Another interesting thing is this. So this is exaggerated volt. And in this case, actually, this lens was implanted upside down, so an incorrect position of the ICL. When you look at the slit lamp, it's not always easy to tell whether the ICL is inverted, but with OCT like this, you can tell exactly that the lens is inverted. And bear in mind, the ICL volt is not the same in an accommodative state or when the pupil changes. And you can see it here. When the pupil constricts, the volt comes down. And it's also very useful to see. It stopped. Can you? No? Let me see. Can you hear me again now? No? Channel 6? Are you on channel 6? Okay. Yeah. Good. So, the OCT from CSO always gives you a dynamic evaluation of the status of the ICL in the eye and the relationship between the ICL and the crystalline lens. You don't see it at the slit lamp, but when you measure it, so in mesopic conditions and scotopic conditions, what you see here that in scotopic conditions, the volt diminishes, so the ICL comes closer to the crystalline. So it's very important that you know this, and that the relationship is a dynamic relationship between the ICL and the crystalline lens. In conclusion, we can say that the anterior segment OCT method is more practical for ICL sizing than UBM, because you need to do contact with the eye with a patient interface with water, so it's much less convenient, much less comfortable for the patient. Using the equation for the L sizing of Nakamura, we can predict the volt and select the appropriate ICL size, and it showed higher accuracy than compared with UBM. It is 72% was within 0.18 millimeters and 95% was within 0.36 millimeters. The non-invasive diagnostic tool, which is the ProOCT gives you a complete anterior segment evaluation, the volt prediction and measurement postoperatively, and the evaluation of the dynamic relationship between the ICL, the iris, and the crystalline lens. I thank you for your kind attention, and so please feel free to ask any questions. Questions, remarks? No questions. So thank you. Have a nice day.